Today we're going to be talking about proportional relationships, reading graphs, and making comparisons. So to begin, we're going to look at a few examples and answer them together. So Ivan buys cheese from the local farmer's market, and this graph represents that situation. Notice on the x-axis it represents the weights, and the y-axis represents the cost. So I can use my graph to find a weight and know what the cost is. So what is the cost of buying no cheese? Well, if I buy no cheese, that's 0 ounces of cheese. So 0 ounces of cheese, if I look on my straight line, it's right there. How much is the cost? 0 cents. What is the cost of buying 1 ounce of cheese? Here's 1 ounce. Here's where it is on my graph. And if I go over to the cost, that is 35 cents. How much, part C asks, how much does the cost of cheese increase for each ounce Ivan buys? Well, to go from 0 ounces to 1 ounce, so from here to here, how much is that an increase of? Well, that's an increase of 35 cents. So for every extra ounce, it costs Ivan 35 more cents. Now, are the amounts given in part B and C equal? And we can see that they are the same, so the answer is yes, but I have to choose between these two. Now, there's always a reason that they are the same, and the reason that they are the same is because they're proportional. Remember, a proportional graph or a direct variation graph means that it crosses through the origin or through the point 0, 0. So my first option. Hey, if it doesn't pass through 0, 0, then the answer to this would have been no. So let's look at a different example. Now we have the Sugar Sweet Company transporting sugar to market. And the graph is showing for a specific weight in tons what the cost of that transport would be. So what is the cost of transporting 0 tons? Well, here's 0. Now I don't have a point at 0, 0. I have a point up here at 0, 1200. So $1,200 to transport 0 tons of sugar. They're going to charge me that no matter what. What is the cost of transporting 1 ton? So here's 1 ton. Go up to my graph. Hey, my point's right here. What is that cost? $2,000. How much does the cost increase for each ton of sugar being transported? Well, to go from here to here, from 1,200 to 2,000, how much is an increase of that? Well, 2,000 minus 1,200 is 800. So the increase is $800. Now, are parts B and C equal, as part D asks? Well, it's not a yes, because 2,000 is not the same as 800. Okay, and why did that happen? Okay, well, does it pass through 0, 0? That's what's going to make those two equal. And I can see that no, it does not pass through 0, 0. So that's out. Okay, so the reason is they're not the same because they do not pass through 0, 0. Okay, let's make sure that we can identify the slope of each proportional relationship. This is going to help us determine or make comparisons between different relationships. So remember, to determine the slope of a table, I take the second column, or the y, and divide it by the first column. So 15 divided by 1 is 15. Now, if it's proportional, it should keep the same pattern, and I can see 30 divided by 2 is also 15. So what is the slope? 15. And if I had to write an equation, y equals 15x. Okay, from an equation, what is my slope? Remember that number next to x is my slope. So I don't have to do any more math than 0.25. Done. From a graph, remember, slope is the rise over the run. So to get from here to here, and pick just 2 points that are close together, okay, to go from here to here, it looks like it's an increase of 1, but make sure you read your table, your graph. It's an increase of 50. And from here to here, it's a change of, from 0 to 1 is a change of 1. Remember, slope is a fraction. Your rise goes on top and your run goes on bottom. So 50 over 1, or 50. Last slope. Okay, if I have this graph, now there's no dots on it, so we're going to make our own dots. we want to find points that cross at perfect ordered pairs. So on these little perfect little grid lines. So I have a point at 0, 0, and as I go along, no, 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 yes. Okay, right here and here. Let's practice that again. No, 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 yes. Now, I only need 2 points, so let's go ahead and find the slope between the first two. From here to here is a rise of 1, 2, 3, and notice that's what my axis says, so a rise of 3 and a run of 1. So my slope is 3 over 1. Now, if I look at each of these slopes, which is the biggest of them? Okay, 50. What is the smallest? 0.25. Let's make sure we remember how to write equations. So 4 divided by 2 is 2. 8 divided by 4 is 2. 24 divided by 8 is 3. So I cannot write an equation for this because the slopes are not the same. 1 divided by 2 is 1/2. 2.5 divided by 5 is 1/2. 3 divided by 6 is 1/2. So remember, this was direct variation, and in order to write an equation, y equals mx is the format I'm going to fill out, and I'm going to replace the m with my slope. So y equals 1/2 x. Alright, write an equation that represents the proportional relationship. A pound of chocolate costs $7. Okay. Dan buys P pounds. Write an equation to represent the cost C that Dan pays. So total cost is C, so I'm going to write C equals, because it says total. Totals always go on their own. Equals, okay, well, what's the cost that Dan is going to pay? My proportional rate is how many pounds of chocolate per pound. So 7 is my slope and P is my variable. Alright, we're going to make some comparisons. So we're going to make some comparisons between student A and student B. So we're at a track event, and the distance that they run is represented by 2 different formats. In student A's case, it's represented by an equation, and student B is represented by a graph. So I want to compare, and I want to see who is faster. That is my big question. Now, remember, who is faster is based on which has the highest rate of change, or the fastest slope. So if I look at the equation, I can see that my slope is 7. If I'm looking at my student B, let's calculate our slope. Well, I can see that there's 2 points drawn in right here, and they're showing me that my run, which goes on the bottom of my fraction, is 3, and the rise is 24. Well, what does that simplify to? 24 over 3 simplifies to 8. So person A is running 7 meters every second, and student B is running 8 meters every second. So which student is faster? The one who runs more meters every second. So student B is faster. Now let's go ahead and graph the equation that's represented by student A so that we can compare this steepness. So student A has a slope of 7. So I would want to rise 7, so here's 8, so I want to rise 7 and run 1, so I would plot my point, rise 7, which is up to 14, and over 1, and plot my point. So notice the student who runs faster is a student that has a steeper line. Alright, last example. If I have 3 hot air balloons and they are rising at constant rates, each of their situations is shown in a slightly different. Each of their situations is shown in a slightly different way. Balloon A is shown by a graph, B by a table, and C by an equation. Part A asks for what is the rate of each balloon's rising. Remember, rate is the same thing as slope. So they're asking for the slope of each of these situations or the rate. So, and we can use those interchangeably. So if I look at balloon A, okay, there's a point here at 0, 0, and as I go along, no, don't put a dot yet, don't put a dot yet. Yes, put a dot. So my rise is up 250, up 500. Make sure you're looking at your axis. So up 500 and over 1. So my slope is 500 over 1. And I can type that in there, or I can simplify it to 500. Balloon B, remember, it crosses through 0, 0, so I can divide 470 by 1. And that is my slope. 470 divided by 1 is just 470. And balloon C, my slope is D, so if my equation says D equals 480t, it's always the number next to the variable. So 480 is my slope for balloon C. So let's compare. Which of the balloons is rising the slowest? Okay, well, remember the slowest is the smallest number of centimeters per second. So balloon C is 470, which is the smallest, so it is moving the smallest. How much does each balloon rise in 3 seconds? Well, if this is how much it travels in 1 second, all I need to do is times them by 3, and that will tell me how fast they are traveling. So 500 times 3 is 1500. 470 times 3 is 1410. And balloon C is 480 times 3 is 1440.